Hello, Mr. Ryan, right?
Hello.
Okay, so suppose that I give you £5. This is the money you have, pocket money. And then you go into a chocolate shop. The price is for each chocolate. For example, like 2,
1,
1, 2. Okay? So you're supposed to buy exactly two chocolates, okay? Exactly 2 chocolates.
Why can't you buy 3?
Good question, because too much sugar is not good. Okay? Just 2.
Or if one of them has extra sugar in it.
Good point. Okay, so let's just take this example. 2
One
chocolates.
1 and 2.
I haven't said the question. Yes, okay. Okay, so the question is that. Okay, so the question is that obviously if you don't have enough money to buy exactly 2 chocolates, then don't buy, okay? And if you have enough money to buy it, you want to maximize the change. So you want to maximize the change. The level of change.
Do you always have to want exactly 2 chocolates?
Yes, exactly 2 chocolates. Okay?
Then what if there's only 2 chocolates? What if it's like 2 and 1?
Good question. Then you just check if you can afford it.
What if there's only one? What if there's only one?
Good question. Okay, so let's say at least 2 chocolates available in store. Okay, that's a very good kind of case. We have.
Why does one chocolate cost more than another?
Good question. Okay, that's not my question to answer. Okay.
That's because one's from Amazon.
Yeah. Some luxury chocolate could cost like maybe 20 or 30. Okay.
But there's not 20 or 30. But what's the other one from?
Let's go maybe.
You just pick the 2 smallest numbers.
Pick the 2 smallest. And you're given these prices, and for each one is represent a single chocolate. Okay, you're not supposed to buy
What if they're sold
multiples
out?
for each one. Sorry.
What if they're sold out?
No, the price you see. Okay, so let's just look at this
What
one.
if the shop is closed?
No, okay, look, 212 means that okay, so there's a chocolate here. You see it, right? Display.
What is a scam?
That's 2.
What if
And here, this is 1, and then here, this is 2.
How come one is bigger?
No, this is the
What
price.
if you're stuck in the queue? or a bunch of people just buy them all?
Let's say you're only customers. You're next to be served. So pick the 2 smallest. Yeah. How do we pick the 2 smallest?
We use Heap.
You know how you
You
said
Heap.
you know how you
Yeah,
said
Heap. Yeah, we can do
you
Heap.
know how you said it's money.
Yeah.
So can you have like, but is it possible you can have 2.111?
2 points.
So for example, if you have this like money, could it be like decimal?
Let's just consider the integer, okay? But that's
Because it's money.
yeah, it's money. But let's just consider integer. We're given an integer representing the prices for each chocolate, and we also given an integer value which will represent the pocket money you have now. And then your task is to buy exactly 2 chocolates. And meanwhile, you want to maximize the level, which is the change. Okay, and then your solution is to pick the 2 smallest. Yes, and we check the 2 smallest, right? And we check if the money is enough to buy the 2 smallest. If it is not, then we just don't buy it. We just return the money. Otherwise, we return the money minus 2 and 1. Okay, for example, you're given 5. 5 minus 2 minus 1 equals 2. So there are a couple of ways we're finding the 2 smallest. Okay, Ryan, you said a heap. Yeah, heap. We can maintain a heap. We can heapify the array, and then each time we heap pop gives the smallest, right? Okay, what's another solution? We want to find the 2 smallest. One obvious way is to
Check
what?
sort.
Sort. Okay, so sorting is good. The third one is that we can.
Play video games.
Okay, so let's say, so I give it 2 numbers. 2, 3,
Silence.
1, 4, 7, 1. Okay. What are the 2 smallest here in this case?
1.
How do you know it's 1, 1?
Because I can see.
Yeah, I know, but how does the computer know it's 1, 1?
You can go through a list
Go from left to the right and
and then you like put a minimum, like you go for the first one is 2, and then you go to 3,
Yeah.
and then so it's 2 and 3, and then you go to 1, so you change 3 with 1 because 3 is the maximum, so 2 and 1, and then 4 you don't take that, 7 you don't take that, 1 2 is the largest out of the 2, so you change that with 1.
Well done, excellent. Okay, so because we are looking for 2 smallest, so we can at the beginning we set 2 smallest to infinity, and then we go through this array, right? It's quite similar to finding the smallest. The smallest is 1 number, so we just go through from left to the right and keep the minimum, right? And then 2 we just keep 2 minimums, and 3 we just keep 3 minimum. Okay, so yeah, we can just do this one go. Okay, so look, min1 and min2, right? At the beginning we set it to infinity, and then we go through from left to the right. Okay, which one is better, is the best, without looking into the code? Which one is the best? Heap.
What's the
So-
third one?
The third one is the one you talked about.
Is it my one?
Yeah, of course. Just go through that. Sorting, right? Sorting. Let's do this sorting first. Sorting. If this is price and this is money, so price dot sort O and log n, right? This is O and log n.
But
And
don't you need to put?
if p0,
You need to put. Don't you need to put what's P and what's M?
define, yeah?
Yeah.
Define, let's say function f p m.
Column.
Oh, we haven't done this column thing for a long time, right? Remember in the early days, I always said, what's missing? And then you just say, column. Yeah? If the 2 smallest is bigger than m, then we return m, right? Otherwise, we return m minus p0.
Emu.
P1. Okay?
Emu.
Okay, that's it. Do you understand this part? What's the time complexity?
Or air. Oh, and log n.
Oh, and log n. Here, this is sorting. Okay. Heap. Let's do the heap. Heap. So, heapify. Heapify, we make it a heap. Heap is like a tree structure, right? The root is the minimum. Let's call min heap. Heapify prices. This is going to take O(n) time. If we are given the array to construct the heap, that's going to take the O(n) time.
Okay, Dad, was this the fake cup?
No, please, can you not do this, please? Okay, where's this thing?
It's in here.
Come on, please. This is very expensive. This one, £2,000 now, okay?
You can sell it.
I can send it to you. You want it?
No.
I send it for half price, £1,000.
No.
I mean, you can buy it and then you can sell it in eBay and then you make a profit. Right? You can sell it easily for £1,500 on eBay. And then you give me £1,000 and you have £500 profit. Make sense?
But Eric
When?
has 700. So 700
Yeah,
to
but I
500.
can't afford half price. I can't afford the price.
Other people would buy it, okay? That's the thing.
No, I'm saying I can't afford half. I can't afford that.
That's okay. I don't need the money right now. You can give me the money once it's sold. Okay. There's always a solution.
Yeah. But if I get that, then I technically I'll get £200 profit because when I have to buy, I got £700 and then the £700 is gone. And then no. So this is how it works. You said since I can't buy half price, which is £1,000, so I don't buy it. So I don't give you the money. So £700 and then it's sold, which is how much did you say? 500? Yeah, you said like £500, didn't you?
No, I'm saying that
No. How much would eBay sell it for?
1,500.
1,500. 1,500. So that means 1,500 plus 700 is 2,200, and then I have to pay you back. So 1,200. So technically, I got £500 profit.
Yeah, that's what I'm saying.
No, you said you. Oh yeah.
Okay, that's it. Heapify, okay? That's going to take O(n) time. And then we check the smallest, 2 smallest, which is that, let's say S equals the heap pop, right? Heap pop P plus heap pop. And then if S bigger than M, return
M.
M. Otherwise,
M.
return S
M.
minus M.
M.
Okay.
M.
Heap pop is that popping a smallest or the maximum in the max heap. Okay, it's popping a smallest element from the min heap. This is going to take O log n time. This is O n. This is O log n. So what's the overall time complexity? Look, O n, heapify O n, and then 2 heap pop is O log n each. So what's the time complexity? Yeah, O n, because look, it's A plus B, right? And we drop these trivial parts. That's very good. Okay, so that's going to take O n time. So this is the same as the third one. Okay, this is O n log n. This is O n. Obviously, this one is better, right? So the third approach. Okay, this is Eric's approach. Okay, let's do this. Eric's approach.
Me approach.
So we want to keep two minimum, right? Min1 equals min2 equals infinity. So we go through this for I in prices. Look, M1, M2. So let's say M1, we want to keep two small lists, right? So M1 is smaller or equal than M2, right? Okay? So we go through this. If I is smaller than M1, so what do we do? Okay, so I have a value which is smaller than M1, so what do we do? Remember the numbers you said, okay, keep tracking the two numbers. M1 smaller or equal than M2, this is the two smallest value. So if I is smaller than M1, so what should we do with M1 and M2?
You get rid of the maximum, the largest one.
So look, current minimum, two minimum is M1 and M2. And then now I found another value which is smaller than M1. So what is the value?
M2.
So M2 needs to be, yeah? Is it?
Yes.
So if I is smaller than M1, then M2 equals M1, right? And then M1 equals I, right? Yes?
Why I?
I is the value here. So let's say M1 is 2, M2 is 3. And now you have 1. 2, 3. This is the two smallest value. And now 1 come in. So what happened? So the two smallest value is 1 and 2, right? So change from here to here. M1, M2. So M2 now equals M1, right? Which is 2. And the M1 needs to be set to 1, right? So it's 1, 2. Make sense?
Yeah.
Otherwise, if I smaller than M2, actually this needs to be equal, right? Yeah, it needs to be equal. Otherwise, I smaller than equal than M2. Then we just need to replace M2. M2 equals I, right? So one example. 2, 3. If it comes to 2, then it will become 2, 2, right? It comes to 3, then it will be 2, 3. Yeah, it's the same. After the loop, we have M1 and M2. So we just check. If M1 plus M2 bigger than M, then return M. Otherwise, return M minus M1 minus M2. This is On, right? Okay? The space complexity, this is O1. This heapify On, because we need to keep tracking. We need to heapify it, and that's going to take On space, a heap. We can do the quick sort in place. Now let's just assume this quick sort is O1 space. What have you learned today?
We learned about spending money, and we want to get the largest amount of money after buying it. And if you can't afford to buy the chocolate, which is when you don't have enough money, or the store is closed, or the chocolate is sold out, you need to return how much money you got already. And we basically are using Heap, sorting, and Eric's way.
Eric's way, yes. Okay, Ryan.
It's my way.
Okay, Ryan. What have you learned today? What's the biggest takeaway?
Me?
Yeah.
You said Ryan.
Oh, Eric. What have you learned today?
Buying chocolate.
Okay. Can you say a little bit more? Come on, please.
So we're buying chocolate.
Yes.
And then we have money, and so we gotta buy exactly 2 chocolates, and there's at least more than 2 chocolates. There's 3 approaches: Heap, sort, and my way.
What's your way?
It's going through the chocolates and I'm looking at the price and just and just kind of
Looking for the tastiest.
noting the minimum, the two minimum, and with those two minimums you just subtract, and then from your money if
I'm not spending chocolate on my money.
if the two minimum, if your money subtract two minimum is negative number, then you don't buy it, and then yeah.
Okay, thank you. Bye bye.